This video presents the solution of various NCERT problems based on spherical mirrors. Let's continue with the first one. The problem states, a convex mirror is used for rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. We begin by constructing the ray diagram for the problem. Since the mirror is convex, the ray diverge and create a virtual image which is erect and diminished. In order to find the position of the image, we will use the mirror formula which is 1 upon f equals 1 upon v plus 1 upon u. Since focal length equals half of radius of curvature, therefore putting the value of radius of curvature as 3, we get focal length equals 3 by 2 or simply positive 1.5 meter. As for convex mirror, focus lies behind the mirror. Here u, that is distance of object, is negative and is given as minus 5 meter as it lies to the left of the pole. We need to find the value of v, that is the distance of image formed. Putting the values into the mirror formula, we have 1 upon 1.5 equals 1 by v minus 1 by 5. On transposing, we have 1 upon v equals 1 upon 1.5 plus 1 upon 5. Taking LCM, we have 1 upon v equals 5 plus 1.5 over 7.5, which gives us 1 by v equals 6.5 over 7.5. Now taking reciprocal on both sides, we get v equals 7.5 over 6.5, which gives us v as 1.15 meter. We can verify that the position of image is correct as the value of v is positive since image lies to the right of pole in the ray diagram. In order to find the size of image, we will make the use of relation of magnification, that is m equals h2 over h1 equals minus v over u, where h2 is the height of the image, so h2 equals minus v over u into h1. Putting the values, we get h2 as minus 1.15 divided by minus 5 into h1. On simplifying, we have h2 as 0.23 into h1. Therefore, the image is smaller by the object by a factor of 0.23. Moving on to the next problem. The problem states, an object 4 cm in size is placed at a distance of 25 cm in front of concave mirror of focal length 15 cm. At what distance from the mirror should a screen be placed in order to obtain a sharp image? Find the nature and size of the image. The distance of the screen basically means the distance of the image from the pole. We will again make the use of mirror formula, but first let's draw the ray diagram for the problem. The height of the object h1 is positive 4 cm as it lies above the principal axis. The distance of the object u is minus 25 cm as it lies to the left of the pole. The focal length of the mirror f is minus 15 cm as the mirror is concave. Putting the values in the mirror formula, we have minus 1 upon 15 equals 1 upon v minus 1 upon 25. On transposing, we get 1 upon v equals 1 over 25 minus 1 upon 15. On taking LCM, we get 1 upon v equals 3 minus 5 over 75, which equals minus 2 over 75. On taking reciprocal on both sides, we get v as minus 37.5. Negative sign indicates that the image lies left to the pole, which can be verified by the ray diagram. To find the size of the image, we make the use of relation magnification equals h2 over h1 equals minus v over u. Therefore, h2 equals minus v over u multiplied by h1. On putting the corresponding values of v, u and h1, we get h2 equals minus into minus 37.5 over minus 25 multiplied by 4. On simplification, we have h2 equals minus 6 cm. Negative sign indicates the image is inverted and negative magnification indicates that the image is real. Moving on to the next problem. The problem states that an object is placed at a distance of 10 cm from a convex mirror of focal length 15 cm. Find the position and the nature of the image formed. For a convex mirror, the focal length is positive and in this case it is positive 15 cm. As the object is always placed in front of the mirror, so the distance of object u equals minus 10 cm as it lies left to the pole. Now putting the corresponding values in the mirror formula, we get 1 upon 15 equals 1 upon v minus 1 upon 10. On transposing we get 1 over v equals 1 over 15 plus 1 over 10. On taking LCM we get 1 over v equals 2 plus 3 over 30, which is simplified as 5 over 30. On taking reciprocal on both sides we get v equals 6 cm. As convex mirror always produces a virtual and erect image, so nature of this image will also be same. Moving on to the next problem. The problem states that an object 5 cm in length is placed at a distance of 20 cm in front of convex mirror with radius of curvature 30 cm. Find the position of the image, its nature and the size. Using mirror formula, that is 1 over f equals 1 over v plus 1 over u. Since radius of curvature is twice of focal length, therefore focal length equals half of radius of curvature, which is positive 15 cm for a convex mirror. Distance of object u equals minus 20 cm. To find the position of image, put the corresponding values in the mirror formula to get 1 over 15 equals 1 over v minus 1 over 20. On transposing we have 1 over v equals 1 over 15 plus 1 over 20. By taking LCM we get 1 over v equals 4 plus 3 over 60, which equals 7 over 60. Taking reciprocal on both sides we get v equals 60 over 7, which is simplified as 8.57, which indicates the image lies to the right of pole. To find the size of image, we make use of relation m equals h2 over h1 equals minus v over u. Simplifying for h2, the equation is reduced to minus v over u into h1. On putting the corresponding values of v, u and h1, we get h2 equals 8.57 divided by minus 20 into 4, which is simplified as 2.14 cm. As the sign of h2 is positive, therefore the image is erect and diminished, as is clear from the comparison with the height of the object. Moving on to the next problem. The problem states that an object of size 7 cm is placed at 27 cm in front of concave mirror with focal length 18 cm. At what distance from the mirror should a screen be placed so that a sharp focused image can be obtained? Find the size and nature of the image formed. Here the height of the object is h1, which is equal to 7 cm as it lies above the principal axis. The focal length of the mirror is minus 18 cm. The distance of object is u, which equals minus 27 cm. The distance of the screen is equivalent to the distance of image, so using the mirror formula, that is 1 over f equals 1 over v plus 1 over u. Putting the corresponding values of f and u we get minus 1 over 18 equals 1 over v minus 1 over 27. On transposing we get 1 over v equals 1 over 27 minus 1 over 18. Taking LCM we get 1 over v equals 2 minus 3 over 54, which on simplification becomes minus 1 over 54. On reciprocal we get v as minus 54. Thus the image lies 54 cm in front of the mirror. To find the size of the image, use m equals h2 over h1 equals minus v over u. On putting the corresponding values of h1, v and u we get h2 equals minus into minus 54 over minus 27 multiplied by 7. On simplification h2 equals minus 2 into 7, which equals minus 14 cm. Here negative sign indicates that the image is real and inverted. Moving on to the next problem. The problem states that we wish to obtain an erect image of an object using a concave mirror of focal length 15 cm. What should be the range of distance of the object from the mirror? What is the nature of the image? Is the image larger or smaller than the object? Draw a ray diagram to show the image formation in this case. It is a known fact that concave mirror produces an erect image only when the object is placed between pole and focus. Therefore, the range to obtain an erect image will be 0 to focal length. Focal length is given as 15 cm, therefore the range comes out to be 0 to 15 cm. So this was it for the video. See you in the next one. Thank you for watching.